This is KM. Welcome you all, my dear students. In the video, class 10 mathematics, chapter 8 statistics and probability, exercise 8.4 இருக்கிற first 5 sums பத்தி பார்க்க போறோம். அதுக்கு முன்னாடி இது வரைக்கும் நம்முடைய சேனலை சப்ஸ்கிரைப் பண்ணாமல் இருந்தீங்கன்னா சப்ஸ்கிரைப் பண்ணுங்க. நம்முடைய வீடியோஸ்லாம் உங்களுக்கு பிடிச்சிருக்கு நீங்கள் ஃபீல் பண்ணீங்கன்னா உங்கள் ஃப்ரெண்ட்ஸோட ஷேர் பண்ணுங்க, லைக் பண்ணுங்க, கமெண்ட் பண்ணுங்க. இப்போ நம்ம வந்து எக்ஸசைஸ் 8.4ல சம்ஸ் பார்க்கலாம். If P of A is equal to 2 by 3, P of B is equal to 2 by 5, P of A union B is equal to 1 by 3, then find P of A intersection B. Solution: first you write the given information. P of A is equal to 2 by 3, P of B is equal to 2 by 5, P of A union B is equal to 1 by 3. We know very well about that addition theorem of probability. So you write here P of A intersection B is equal to P of A plus P of B minus P of A union B. You substitute the values for P of A, P of B and P of A union B. So now 2 by 3 plus 2 by 5 minus 1 by 3. Now you take the LCM for the denominators. So 15 is our LCM. Equalize the denominators to 15. So the first term 2 into 5. So 5 divided and multiplied by 5. So 2 into 5, 10. The same thing, second denominator is 5. You multiply and divide by 3. So now 2 into 3 is equal to 6. Then the third one is you multiply and divide by 5. So 1 into 5 is 5. So 10 plus 6 minus 5 whole divided by 15. Now you simplify. If I add the 6 plus 10, 16 minus 5 is 11. 11 by 15. Then go to the second sum. A and B are two evens such that P of A is equal to 0.42, P of B is equal to 0.48 and P of A intersection B is equal to 0.16. Find, there are three problems. Given P of A is equal to 0.42 and P of B is equal to 0.48. Now the first question is P of not A means P of A bar. You know the formula. P of A bar is equal to 1 minus P of A. So 1 minus, you substitute 0.42 for P of A. So 1 minus 0.42. Now you subtract 0.42 from 1. We get the answer is 0.58. Then second question is equal to P of B bar. So you know the formula for P of B bar is equal to 1 minus P of B is equal to 1 minus, you substitute 0.48 for P of B. It is given. So now you subtract 0.48 from 1, we get the answer is 0.52. The third one is P of A or B. So now P of A or B is equal to P of A union B. You write the addition theorem of probability. So P of A union B is equal to P of A plus P of B minus P of A intersection B. You substitute the values 0.42 for P of A plus 0.48 for P of B, then 0.16 for P of A intersection B. Now you add the two numbers 0.42 plus 0.48. Here the answer is 0.90. Then you subtract 0.16 from 0.90. We get the answer is 0.74. So the answer is 0.74. Third question is, if A and B are two mutually exclusive events of a random experiment and P not A, that is P of A bar, is equal to 0.45, comma, P of A union B is equal to 0.65, then find P of B. Given number 1, P of not A is equal to 0.45. You know very well about that. P of not A is P of A bar equal to 0.45. Then we want to find P of A is equal to 1 minus P of A bar. Now you substitute 0.45 for P of A bar. So 1 minus 0.45. We simplify, we get the answer for P of A is 0.55. Then the second information is P of A union B is equal to 0.65. So since A and B are mutually exclusive events, so you write the formula P of A union B is equal to P of A plus P of B. Here you know the values for P of A union B and P of A. So you substitute 0.65 is equal to 0.55 plus P of B. Then here 0.65, you take 0.55 from right to left, the sign is changing. So minus 0.55 is equal to P of B. You subtract here, we get the answer 0.10 is equal to P of B. That is P of B is equal to 0.1. Now the fourth question is the probability that at least one of A and B, that means P of A union B, at least one of A and B means P of A union B, occur is 0.6 if A and B occur simultaneously with the probability 0.2, that is P of A intersection B is 0.2. Then find P of A bar plus P of B bar. Solution, given the two information, P of A union B is equal to 0.6. Then P of A intersection B is 0.2. We know that you write the addition theorem of probability. P of A union B is equal to P of A plus P of B minus P of A intersection B. Here you substitute the values for 0.6 for P of A union B is equal to write P of A plus write P of B. Now you substitute 0.2 for P of A intersection B. That is 0.6 is equal to P of A plus P of B minus 0.2. So you take 0.2 minus 0.2 to left side. We have 0.6 plus 0.2. Here minus 0.2 you take to the left side. It is positive. So you add, the answer is 0.8. Here is equal to P of A plus P of B. P of A plus P of B is equal to 0.8. This is equation number 1. But we have to find P of A bar plus P of B bar. So you write here P of A bar plus P of B bar. You know the formula very well about that. P of A bar is equal to 1 minus P of A. You write plus. Then P of B bar is equal to 1 minus P of B. You add the two numbers, 1 plus 1 is equal to 2. Here P of A is minus and P of B is minus. You take two common minus. So 2 minus P of A plus P of B. So 2 minus, you substitute 0.8 for P of A plus P of B. Here the answer is equation number 1, 0.8. So 2 minus 0.8, you subtract 0.8 from 2, we get the answer is 1.2. Therefore, P of A bar plus P of B bar is equal to 1.2. Then we go to the last sum, that is fifth sum. The probability of happening of an event A is 0.5 and that of B is 0.3. That is, here P of A is given, the P of A is 0.5 and P of B is 0.3. If A and B are mutually exclusive events, then find the probability that neither A nor B happen. Solution, given P of A is equal to 0.5 and P of B is equal to 0.3. Since A and B are mutually exclusive events. So for this, we write the formula P of A union B is equal to P of A plus P of B. Here you substitute the values for P of A and P of B. Therefore, P of A union B is equal to here 0.5 plus 0.3. Here if you add the two numbers, 0.5 plus 0.3 is 0.8. Now we find P of A bar intersection B bar. That is, find the probability that neither A nor B happen. Therefore, P of A bar intersection B bar is equal to P of A union B whole bar. You already studied the De Morgan laws for complementation. Here you substitute for this. Therefore, P of A bar intersection B bar is equal to P of A union B whole bar. So now is equal to 1 minus P of A union B. 1 minus, what is the value for P of A union B? A union B is equal, P of A union B is 0.8. Therefore, 1 minus 0.8. So we simplify, we get the answer is equal to 0.2. This is the answer for P of A bar intersection B bar.